Okay, applications to economics. Raise your hand if you're taking econ right now. Raise your hand if you're taking econ right now. That's not you. You took it last year. Okay. So these applications will not come up in your economics course because your economics course is not calculus based. But it's still good to think about some of these ideas and principles. It is required by Riverland that we cover this topic. We just spent a day on it. Cost function is C of X. The average cost function, suppose, who wants to produce something? What do you want to produce? Sandwiches. Okay, Maddie's going to produce sandwiches. All right. So she produces 100 sandwiches, and it costs her $100. Okay. So how much does it cost her per sandwich? $1. How do you find that? You take the cost, and you divide it by the number of items that you produced. You should hopefully remember that from earlier this year. The marginal cost function is C prime of X. C prime of X means the cost of producing the next item. So for example, when Maddie first starts making sandwiches, it costs her about $3 to make each sandwich. Why? Because she's not very careful with things, and she's not very practiced. But after she's produced 10, she's quicker, she's more efficient, she's getting better ingredients for better price, and so you know, the cost is dropping for her. Good for her. Yeah, you could, you know, the marginal cost function would then just stay the same. So, yep. So we are going to talk about minimum average cost. So the idea in this lesson is that we want to take our average cost function and we want to make it as small as possible. So, you know, it's costing her $1 to make each sandwich. We would like if we could get it down to, say, 75 cents. At what point does that occur? Does she have to make 20 sandwiches, 100? You know, where's it at? Well, if we want to minimize something, you've learned in calculus, in order to minimize, we take the, instead equal to. So let's take C of X divided by X, and let's take the derivative of that and set it equal to 0. In order to take that derivative, what rule do I have to use? The quotient rule. Derivative of the top, C prime, times the bottom, minus derivative of the bottom is times C of X, all divided by, that's equal to 0. Are we concerned where the bottom is equal to 0? No. The bottom is equal to 0 at 0. That would mean we would have no items produced. Okay? We don't want to do that. So let's just look at where the top is equal to 0. And if we rearrange some of these terms, we're going to come up with an interesting equation. We get C prime of X times X is equal to C of X if I just add the cost function over to the other side. Does anybody see the next step I can do? If you divide by X, you come up with our final expression, which is C prime of X is equal to C of X divided by X. What do we refer to C prime of X as? Marginal cost. So when the marginal cost function is equal to, what is C of X over X? Average cost. So when those two are equal, that is when you have minimized the average cost function. Every time. So it says here minimize average cost. That happens when C prime of X is equal to C of X divided by X. Now, Maddie's producing sandwiches. She makes 10 of them. Okay. She's going to sell them for $2 a piece. What is her revenue? $20 is her revenue. Okay. That's what she's made. All right. Now, she doesn't get to keep all that because she has cost. But the fact is that she has some revenue. How did she get that revenue? Well, she has to consider the price. Okay? There's a price function. Now, suppose that Maddie is selling sandwiches at lunch, and suppose she's selling sandwiches in the morning. When do you think it would be more beneficial for her to raise the price? Lunch, because it's more in demand, right? So that's why price is a function. It's a function of the demand. If she wants to know how much revenue she actually gets, she takes whatever she's charging. So if she's charging $2 a sandwich, she has to multiply that by the number of sandwiches that she's actually purchased, or I'm sorry, that she's made and sold. So if you want to find revenue, you take X, the number of items you've sold, times the price at which you sold them. Marginal revenue function is going to be just R prime of X, the expected revenue for the next item that you've sold. Can somebody now, because obviously in economics we like to minimize cost, but we like to maximize profit. Can somebody give me an equation that involves profit, revenue, and cost that relates the three together? Profit is? Use revenue and cost. How do you figure out profit? Yeah, R minus C. You take your revenue and minus your cost, that's your profit. If you want to know the marginal profit function, then it's P prime is equal to R prime minus C prime. So the big question we have is, what about maximizing profit? Again, if you want to maximize profit, profit function is P of X is equal to R of X minus C of X. I would like to maximize that profit, so I will take the derivative and set it equal to 0. P prime of X is equal to R prime of X minus C prime of X. Profit equals 0. I'm sorry, derivative of the profit is equal to 0. Anybody know what I can do to make this look a little bit different and useful? Just add the C prime over the other side, and we get C prime of X equals R prime of X. So the question is, when does the maximum profit occur? When the marginal cost function is equal to the marginal revenue function. When that happens, we have maximum profit. So I will give to you on the test this stuff right here. Okay? I'm going to give you that. Oh, well, Jake, if you would like to memorize it, challenge is extended your way. Okay. All right. The fact is, you will never have to use this again. You won't have to use it on the AP exam, and so I don't think it's worth our time to really focus on memorizing it. I just want you to be able to use it. Okay. River only requires, yes. It's not an AP exam, and the AP exam requires stuff that you will never see again in your entire life, no matter how much math you take. So, gotta appease both groups, so we do it. So, let's do some basic examples. The cost of producing X items is C of X equals 2,600 plus 2X plus that. Find the cost of producing 1,000 items. I'm going to use my calculator to try to save time. I'm going to type in my cost function, Y equals, and looks like I have a different one in there right now, but 2,600 plus 2X plus 0.001 X squared. So the first question is, find the cost of producing 1,000 items. What should I do? Go to my table and type in, and I get 5,600. So the cost of producing 1,000 items is $5,600. Now it wants the cost to produce, or the average cost for 1,000. Yeah, take 5,600 and divide it by the number of items, $5.60. Now it says the marginal cost of producing 1,000 items. What is the formula for marginal cost? The derivative. What is the derivative here? C prime of x is. So I'll go into y equals. I'll type that in for my y sub 2 value. 2 plus 0.002x. And as I go to my, whoop, I did that last hour as well. Go away. If I go to my table, I get y sub 2 is 4. So the marginal cost is $4. What does that even mean? Yeah, the cost of producing the 1,001st item will be $4. So doesn't mean the cost of producing 1,000 items is 5,600, but it looks like we weren't quite as efficient early on. Maybe it cost us $10, $8. But now we're at $4, so it's starting to average out better for us. Okay. All right, and then we get to the main point for today, is the production level that will minimize the average cost. So I can give you the formulas, but you have to be able to interpret this on the test to understand what formula you pull. If you're going to minimize the average cost, what's our formula for minimizing average cost? Very good. That's the formula I use. We have C prime of x. It is 2 plus 0.002x equals C of x is 2,600 plus 2x plus point all over x. Thoughts on solving this? Multiply the other side by x, 2x plus 0.002x squared equals 2,600 plus 2x plus 0.001x squared. What happens? The 2x's go away. If we add or subtract the 0.001x squared over, we get 0.001x squared is equal to 2,600. X squared is 2,600,000. We square root. What's that? Voice is fading off and just can't quite catch her. 16, 12.45. Okay. There's debate among people. Do we, round up, round down? The company can decide what they want to do for rounding. Okay. Can you have partial units? Yes. For example, in teaching, can you have a 0.5 teacher? Yes. That's a half-time teacher. Okay. You can have partial units. Okay. Now, if you're going to produce sandwiches, can you have a half a sandwich? Well, sure. Why not? Maybe somebody just wants to purchase a half a sandwich. Okay. Yeah, cut it diagonally. There you go. Or maybe she would eat it herself. Or maybe she would take the one piece of bread and fold it over. Okay. So let's try to get to the... here's the question that came up first hour then. Okay. So if we should produce 1,600 items, and I wanted to find the average cost of producing that number of items, what would I do? Plug it into the cost and divide it by 1,612. Yep. Okay. We'll at least get started here, and this is all we have for the rest of today, and you'll have time to work. So given a company has a cost function of that and a price function of that, find the maximum profit for the company. In order to find profit is equal to R of x minus C of x. Right? But it says to maximize the profit. Well, maximum profit occurs when R prime of X is equal to C prime of X. Do you even know what R of X is yet? Your formula says that to find R of X, we take X and multiply by P of X. So the number of units that we produce and sell times the price function. Do I have my price function? Yeah. So revenue is equal to 3.5x minus 0.01 x squared. Now I have a revenue function for, so I can find a derivative, and I have a cost function right there. I'm just reminding myself that, oh yeah, I multiply an x through. Yep, good question. Okay, so I take the derivative of revenue. What do I get? Equals? Got to take the derivative of that guy, right? 1.26 minus 0.02x plus 0.12321x squared. What happens? Gone. Combine some like terms. 3.5 minus 1.26. I get 2.24. If you could quick solve that. Yes, it was a telemarketer. Okay, so what did you get for X? So 103.28 items. That is what we should produce in order to maximize our profit. That's valuable for a company to know, right? Okay. The very last question that we have is this piece right here, which says the production level at which the marginal cost begins to increase. Well, the marginal cost we already wrote down. It was the derivative of C, which was C prime of X is equal to 1.26 minus 0.02x plus 0.00021 x squared. Let's think about this. What shape does that make if you graph it? Is it increasing or decreasing right here? Increasing. So I want to find the point at which it increases. We'll do that when we get back. The second derivative instead equal to 0. Yep. The question is, the production level at which the marginal cost begins to increase. This is the marginal cost function. You said it looks like a parabola. It's, right side up. It's decreasing here. It's increasing here. So when is the point at which it changes? Where the derivative is equal to 0. So that would be the second derivative. So I take the derivative of the derivative, C double prime, is equal to what? Negative 0.02 plus 0.00042x. Solve that. 0.02 is equal to 0.00042x. Divide both sides by 0.00042. And I get 0.02 divided by 47.62. So 47.62 units is when the marginal cost begins to go back up. Okay. No, it's fine. Yeah. Oh, I'm sorry. Yes. So technically, we won't do that here because I don't think you have to do that for your assignment. Um, I should have asked how many items should be produced in order to maximize the profit. But the question is, what is the actual maximum profit? So this is items. This isn't your profit. So you would take this and plug it back into your profit function. And we will look at that further when we do the study guide. Okay. But we'll just leave it as the items for right now. Good to go? Your assignment, 4.8, page 293, numbers 5 through 7, 11 through 13, and 15 and 16. Yes. I'm going to take it home tonight and burn it.